Oh gosh, let's hope they will come through. Oh, you started the recording. Okay. Time is it? Okay. While I still have 5 minutes, let me share my screen. Okay, so this one is that one where we have to say, they must write in the chat. Hello, Maneti. Can you
Hi,
hear me?
Miss Boy, how are you?
All
Yes, I
right,
can
and
hear
now
you.
I was scared that I'm the only one here today. So I'm going to give it another 3
Oh,
more minutes to see if people are joining. Then we will start.
okay. Okay, while we are still waiting, Miss Boy, can I just quickly ask something, but it's not related to statistics.
Fine.
I wanted to ask that are they responding to the administrators in Cape Town working off-site? Are they able to respond to our queries when we send in emails?
There should be. There should be, even if they are working from home, as long as you send an email, it goes into an inbox where they should respond. Can I ask what was the query
Yes.
about? Because also
Okay.
depending on the email you used.
Okay, no, my situation, I wrote an email to them, and then I saw on my UNISA online that we need to actually fill in a form for the AgroStats.
Okay.
I'm having like a medical condition.
All right.
So then, yeah, since I've been navigating through my UNISA, there's no form or any link. So I got the PDF form and then just fill it in, and then I scanned it and I returned it back, but I haven't like received any response from them.
Which email address did you use?
Okay, I used the Cape Town at UNISA, the Cape Town, yes, Cape Town at unisa.ac.za. And then I also used the AgroStats email address. I got an auto response from both. With the
Okay.
AgroStats, they told me that I should go online, which is there's nothing online that I can fill in. And then with the Cape Town, they just gave me the case number.
Okay. So when you go online, you can't find the information you're looking for.
No, I can't find anything. There's nothing because they said you go to your administration tool and then you go to examination tool, and then that's where you'll find the form that you need to fill in online. But there's no form, there's nothing.
If you go on your My UNISA, didn't they say on My
Yes.
UNISA? And then
They
you
said on my UNISA. I went on
okay.
my UNISA. Yes.
Did you log in as yourself and go
Yes,
to
I
your
logged in. Yes, I
okay.
logged in
Yeah.
and then went to administration as they instructed, as per their instruction, and then checked on the examination tool, nothing. I even started navigating through the whole administration system, but there was nothing. Everywhere you go, it's just information. Even with the examination or the AgroStat special examination, it's the very same thing. They are
Okay.
just giving out instruction on what you need to do, but there is no link or a form that you can be able to fill in.
Then you must send them again another email, the agrotech department, to say they must forward you the email, the form.
Okay,
And
I
explain.
have the form. Yes, I did that. It's the third email that I've sent to them. I first made an inquiry,
Oh,
and then
okay. So
yes, and then
sure.
secondly, I asked for the form. They didn't respond, so I had to get the form from a previous student who is still at UNISA as well. And then I submitted the form. I got an auto response as well. No one is actually like responding with a proper like explanation on what is it that I need to do.
Because I see here they say you must do it online. I think it should be an online application form that you complete. It's not a hard copy. So when you log in onto My UNISA, you must go to the examination timetable. And
I've been there.
it should you should have the online application for the agrotech. And then
Okay, I've
you must attach your medical certificate and give full details as to why you want to be exempted from writing the exam. Maybe
okay,
check
ma'am.
again if there is a link somewhere to apply. So from where I'm looking at the information here, it seems like you need to do it online. You can submit a form. You can't download a form and do it. You have to do it online.
Okay, my issue was when I go online, I can't find where I need to fill in that form.
So you went to the examination timetable too?
Yes.
And then on there, did you go to the administrative section?
Yes, I went there as well.
Maybe after the class. Oh, but I have another session. Oh gosh.
No, I can arrange with you on what time are you going to be available so you can assist me.
Did you ask me on WhatsApp or on?
Yes, I did ask you, but unfortunately you requested that everything we should send it to the group.
Was it you?
Yes, it was me.
I don't read the private messages. I delete. I delete even before I get tempted to read them. Okay, so after class I have a session. Let's do it at 8 o'clock.
At 8 o'clock. Okay.
Yes. So on the group there, you can just say it's me, and then I will know it's you. I will call you.
Okay. All right. No problem, ma'am.
Then we can do it together online. Okay. So.
Okay. No problem. Thank you.
Yeah. Since we the only two people, I don't think that people are going to join the session today.
I wonder why are people, because even with myself, I'm just doing because at the end, I'm still going to do this module, even if I'm not going to write, but I'm still going to do this module.
I don't know. Did you guys receive an email to tell you that there is a class? I think people wait for the email. If the email doesn't come through, they don't think that there will be an email or there is a class, which is a problem. They don't receive. So it's fine. We can just continue with our class. It might even be quick because it's only the two of us, unless someone joins and I don't see them. Okay, so please write your student number on the chat since we don't have the register functionality. And today we're going to do non-parametric statistic, which is the Wilcoxon test. And we're going to look at the Wilcoxon test, rank sum test, and then we're also going to look at the sign rank test. I know that there is another method, but since it's time limited, I'm only going to concentrate on those two. With the rank sum test, I'm only going to look at where when we have a small sample and when we have a large sample. And then we will do the paired one and we'll do some more exercises. So let's look at Wilcoxon rank sum test for the differences in the two medians. By the end of this 30 minutes or this session or the hour that is coming, you should be, or 2 hours actually, you should be able to know how to use the Wilcoxon rank sum test for two population medians, and also to be able to present the Wilcoxon signed rank test if we compare two paired samples. What do we use this for? We use the Wilcoxon rank sum test to test if two independent samples medians are the same. We test that. We also need to make sure that the population, the population should not be normally distributed. Like we need to make sure that the population is normally distributed, but for this, the population does not have to be. And because this is a distribution-free procedure, so it doesn't follow any distribution side, like if it's skewed or right skewed or left skewed, no. This is a free distribution procedure, and we use it when we only want to rank the data that is available. And we must use normal approximation. especially if our sample sizes are smaller, but we need to make sure that they are larger than 10.
Okay, larger than 10. Okay.
Yes. But if both of them are smaller than 10, which is where the small sample size method comes in. If both the samples are smaller than 10, then what we're going to be doing, we're going to take the rank of all the sample size together. So we're going to combine both the sample size and rank the values, and and then place the rank for each one of them. So depending on the value, so from smallest to highest, and then we just rank them to say we give them the rank number 1, number 2, number 3, number 4, number 5. And once we have ranked them, then we sum all the rank values together. And both those rank values, one will, for the sample size 1, all the values that comes from sample size 1 will be called T1, and all the values, the rank sum values that comes from sample size 2 will be called T2. And for the test statistic that we're going to use to make decisions later on, we're going to use the sum rank value of the smallest sample size. So if both of them, if one, let's say sample size 1 had 5, or let's say yes, has 5 values, and sample size 3 had 7 values. So we're going to take the T1 from the smallest one, which is T1. And checking the ranking, we use this formula. We take T1 plus T2, which is n times n plus 1 divided by 2. And this is just to check the rankings. Remember now, your n will just be sample size 1 plus sample size 2. That is your n. And we substitute it into the formula. So if they had 5 and 7, so it will be 7 plus 5 will be 12. And those will be our n. So we'll say 12 times 12 plus 1 divided by 2. And that will give us the ranking sum. To make decisions, when we do the hypothesis testing, since we're looking at the difference between the two medians from this population 1 and population 2, so then there will be, like we do with hypothesis testing, all the 6 steps of hypothesis testing, when we state the null hypothesis and the alternative hypothesis, we're going to say for a two-tailed test, we're going to say the median of population 1 is equals to the median of population 2. Alternative, it will say they are not equal, because then it will be not equal. And when we make decisions, if it falls between the lower limit and the upper limit of T1, I will show you how to find those critical values on the tables. We're going to determine what our upper limit is and our lower limit is from the values. And then if it falls within those two, then we reject if it falls in the less than side of things, and we do not reject if it falls in between. For the left-tailed test, then we say the median for population 1 is more than the median for population 2, or it's at least, or it's bigger than, or equals to the median of population 2. The opposite will say it is less than. And therefore, since it's less than, therefore it will mean we're going to look only at the lower limit side when we do the rejection. Anything that falls in the lower limit, we reject. And anything that falls in the upper limit, we do not reject. And then for a one-tailed test in the right side, where we say the median of 1 is less than or equals to the median of 2, the opposite or the alternative hypothesis will say the median of 1 is more than the median of 2. And with that, it means we're only going to have one rejection area in the upper side area. And anything that falls in the bigger than our critical value there, we're going to reject. Anything that falls in the left of the T1U, which is the T1 upper value, we do not reject. And that's the hypothesis and decisions. Then if we, let's look at an example of how we apply all that, what we have learned. So a sample size, a sample data are collected on the capacity rate, which is the percentage of capacity for the two factories. We want to find out, are the median operating rates for the two machines, are they the same? So the minute they say, are they the same, it means, are they equal? So for factory A, we have the rates as 71, 82, 77, 94, and 88. And for factory B, the rates are 85, 82, and 92, 97. And we need to test this at 5% level of significance. So the first thing we do is we need to combine the two and then rank them in order. So the first thing that you do is you make sure that your data is ordered in from highest to lowest. And if we look here, we have factory A, it has all the values. And because we want to also slot the factory B values, and there are your factory B values. So that is 82, 82, 85, 88, 92, 94, and they are all in order. And then now we can place their rank from 1 to the last one. So when we do the ranking of the values, if both the values share the same number, let's say 82 and 82, so it means we're going to take the average of the two. So with this instance, 82 and 82 are in, one is in position 3 and one is in position 4. So we're going to split the position between the two. So it means it will be 3.5, 3.5 for both of them. And then we don't also continue and say 4 because we already accounted for it. So the next one will be the highest value after 4, which is 5. And then this one will be 6. And that one, 92 will be 7, and 94, 8, and 97, 9. So all in all, we have 9 values. So once you have ranked your data, you add all of the ranks. So for factory A, you add all of them. And we can find that for factory A, the rank is 20.5. And then we also add the rank for factory B. So for factory B, the rank is 24.5. So that is the sum rank. So once we have both the sum rank, if I go back to the factories, so remember that our factory 1 had 1, 2, 3, 4, 5 had n is equals to 5. And for factory B, n was 1, 2, 3, 4. So n is equals to 4. And remember from the beginning we said we're going to take the T1, which is our test statistic. It will be from the smaller sample. So it means we're going to take it from the n value that it has lesser values. So this one has 5 and this one has 4. So therefore it means we're going to use the sum rank of factory B. So if we go here, these are the sum rank for factory B, which will be our T1, is equals to 24.5, and that will be our test statistic. Okay. Since T1 had factory B had smaller sample size. Now we need to go and find the critical values. Since we're going to reject the null hypothesis, alpha is equals to 0.05, remember that. We need to take our T1 and alpha value and go to the critical values of Wilcoxon rank sum test table. So I'll show you. I think I have a slide. Yes, I do have a slide. So you go to table 6. If you look at the tutorial letter 101, they are tables at the back of your tutorial letter, I guess. If not, you must look at the past exam papers. They should have these tables as well. So what you do, you go look for critical values for the Wilcoxon's rank sum test. And what you do, Remember, we had N1 and N2. Remember that. So our
Yes.
N1 had N1 had in that exercise
N1 had
I swapped them around. So what we did, we took the one with the smallest, we made it N1. So it means the one with the smallest, we make it N1, and the one with the largest, we make it N2. And you come here and you look for N1. So the top one will give you the N1, which is 4 N1. So we're taking the smallest one. So N1 is 4 and N2 is 5. And both where they meet, it's 11, it's 1228. So our upper limit, remember, because the null hypothesis said we must test for the median are equal, which is a two-sided test. So the upper limit will be 12, the lower limit will be 12, and the upper TU, which is the upper limit, will be 28. So we're going to look at our T1 and those two upper limits to see where they fall. Oh, the other thing I forgot to mention is you need to look at the what do you call this thing now? The alpha value. So you also have to go to the alpha table, and since we're doing a two-tailed test, so it means for this we'll divide alpha by 2, which will give us 0.025. Sorry, we're not dividing by 2, so we'll take the alpha of 0.05, which is a two-tailed test, and then go make a decision. So now, how we make a decision, we know that our alpha was 0.05, and our N was 4 for N1, and N2 was 5, and then we went and we found our T values for the lower limit and the upper limit. So that will be our rejection area. So if our T1 that we got from selecting the sum ranked, our test statistics, which was 24.5, we need to find where it falls. Does it fall in the rejection area, or does it fall in the do not reject area? And if we look at it, it will fall somewhere in the do not reject area. In the do not reject area. So therefore, we do not reject the null hypothesis, and we can conclude by saying there is not enough evidence to prove that the medians are not the same or are not equal. And that's how you do the rank sum test. So let's look at an exercise. We can do this together. So on this exercise, what they did, they calculated already the sum ranks. They gave us T1 and they gave us T2 and N1 and N2. And we can see clearly that our N1 is smaller. So that is our smallest one. So therefore our test statistic, which is T1, will be equals to 42. If we follow what we did. So now we need to go to the table to go find our, on the table at alpha of 5%, we will have to go and find what our critical values are. But before we do that, we need to also make sure that we understand what we need to be calculating. So the test that we need to use, we use the Wilcoxon rank sum test to determine at 5% level whether the location or the median of the population 1 is to the right of the location of population 2. And that, it means, is it to the right? It means it's greater than it's greater than or equal. So therefore, since it is to the right, and remember in the null hypothesis, we always going to have the equal sign. So this says is to the right, it means the opposite will be the our null hypothesis. Let me get my pen so I can write this. So it means our null hypothesis will be the median for one is greater than, oh sorry, it will be equal. It doesn't matter what we put there. Equals to median of 2. Our alternative will be our median 1 is more than median 2 because it says it's to the right. So therefore it means it's more than our median of 2. So in your null hypothesis, it does not matter whether you put the equal or you put, it doesn't really matter. What matters the most is what goes into your alternative hypothesis. So now we also know what our T1 is, which is our test statistic, is 42, and we can go and find the critical value. So since also we're doing only one side, therefore it means we will have T1U, which then it will tell us if anything falls in this side, we will reject, and if it falls this side, we do not reject the null hypothesis. So we need to go and find out our critical value on the table and using our alpha as well. So if we go to the table, we go to the table, you must look for table E6, critical values of Wilcoxon rank sum test. And we're looking for, remember now, it's only one-sided tail, it's one tail. So we need alpha for one tail. So it will be on number 2, if you look at the bottom of the one at the top, or maybe I should share my screen so that we can all see what I'm referring to. Please make sure that you write your student number on the chat for the register purpose. Thank you, Candice, for writing. So others, you might follow what Candice is doing while I am trying to share my screen. Okay, so on this, we need to go look for our critical value. Remember now, our N, oh, I didn't write what our N is. It was 9 and 6. So our N1 was 6 and our N2 was 9. So we know that our N1 was 6 and our N2 was 9. And we're looking for alpha is equals to 0.05 for one tail. Remember that? It's a one tail, so we're looking for this one. We'll be on the B. And just to double check my N's as well. N1 was 6 and 9. Yes, I'm right. So go back to the table. Then at the top, we're looking for N1 here at the top. N1 was 6. So we're looking for only the upper tail. So it's fine. N1 was 6 and N9. So if I take both of them, it will be 33. I can just write them 33 and 63 for both of them. It's fine. Then we must go back to the table. Let's go back to the presentation so that we can answer the the question. So now we know what our T1U is. Let's start with L. Is the upper tail, lower tail was 33, and T1U, which is the upper side, the upper limit, we found that was 63. Okay, and we know that our test statistic is that it's 42. So now we can come and answer the questions based on the information that we just collected. We know that should always stay the same because it says the two population means medians are the same, so it's fine. Because always in your null hypothesis, I did right there, your null hypothesis, we can always say the median for 1 is equals to median for 2. It doesn't really matter. What matters the most is what we write in the alternative hypothesis, which states that the median for 1 is more than the median for 2, because it says the median for 1 is to the right, is to the right of the location of 2. Oh yes, the median for 1 is bigger than the median of 2. Yes, is to the right means is bigger than. So this hypothesis testing, it says the median for 1 is to the right of the median of 2, which is what the statement has just said. We just repeat that because yes, it's in the null hypothesis. So that will be correct in the alternative hypothesis. Then it says the region of rejection will be less than 33. It cannot be T limit 1 less than 33 and T limit 2 will be less than more than 63. So that is if we have 2 tails. So remember, because this is not a distribution thing, so if it falls between, it would have been, if it's a 2 tail, it would have had T1U and T1L and T1U. But since this says to the right, so we only need one side. We don't need both of them. So anything this side, do not reject. Anything that side, we reject. And the test statistic, we know that was our test statistic. It's 42. We take the test statistic of the smaller sample size, which is n is equals to 6. So it is the smaller sample size. I will come back to that one. And in conclusion, we take this 42 and we go and look at this. Where is our rejection? If T1 is 42 and we went and found the critical value was 63 there. So our T1 of 42 falls somewhere inside. They do not reject region. But because this is the rejection area anyway, so in conclusion, the two populations are not the same and we reject the null hypothesis. That is the incorrect one because we do not reject the null hypothesis since it falls in a do not reject area. And that will mean they used both the upper limit and the lower limit as we find them on the tables, and that's what they did there. They used that, but because it says it's more than, so we just need to use one side of the table, which is the rejection area should have been just on one side, not on the other side. Any question? Any question? If there are no questions, then we can move to the larger sample size. So now let's look at how we do the Wilcoxon rank sum test for larger sample size. Okay, I think there are things missing on there.
Can I please? I'm sorry.
Yes. You want to ask a question?
Yes. So when it says like I wanna know how do we know to use the right tail or to use the left tail or both?
Okay, so when the question, remember that how you state your null hypothesis and your alternative. So sometimes it will be clearer. They will say, for example, the mean are the same. So the median are the same, or the location are the same. So therefore it means they are equal, né? And the opposite will
Yes.
say they are not the same. What matters the most when we do hypothesis testing is not what we put in the hypothesis, in the null hypothesis, because in your null hypothesis, the statements that you put in your null hypothesis always have to have an equal sign, regardless of whether it's greater than or equal or less than or equal. There will always be an equal sign. But we don't use that statement for any decision. We use the statement that we put in the alternative. So if they say it's equal, it's a clear distinct that in your alternative, it will say they are not the same. So it's not equal.
Right.
And then sometimes they will say the mean is greater than. But the greater than, we cannot put it on the null hypothesis, because every statement you want to prove is what the researcher wants to prove. And what the researcher wants to prove is always in the null hypothesis. But the minute they say it's greater than, so it means it's more than, then we put it in the alternative as greater than, as bigger than, as more than. If they say it's less than, or it's below, or it is to the left, then it's less than. Then we put it in the null hypothesis as a less than, and in the in the alternative hypothesis as less than, and in your null hypothesis you can just put the equal, or you can put the greater than or equal. So, but in the statement they will state it. So, for example, like this one, it says test for the equality, which means that in the null hypothesis you will say it's equal, and then in the alternative you'll say it's not equal. And on the exercise that we just did now, they didn't use the words like it's equal or it's less than, or, but they just tell you where place the mean of population 1. They say it's to the right of your population 2. Anything that is to the right of that, it means it's bigger than the population 2. So it means it's greater than. And probably during the course of the session, we will have other example. Maybe they will have a less than, or they will have a greater than. I can't even remember. But let's see what happens, and then you can see how you recognize whether you need to use one-sided test or two-sided test. Okay, so let's look at.
Thank you so much. Yeah, understood.
No problem. So let's look at the large sample size. So with large sample size, what happens is our test statistic will just always be our T1, and it will be approximately normally distributed with the mean of T1 and the standard deviation of T1, but the mean will be calculated by using that formula. Now, remember that our N is the sum of the two. So our N would have been N1 plus N2. With the mean, we calculate it by using N1 times N1 plus N2, which is our N plus 1 divided by 2. And our standard deviation for T1 is given by the square root of N1 times N2 times N plus 1 divided by 12. If our N was 4 and our N1 was 4 and then N2 was 5, then it means it will be, for the mean, it will be 4 times N1 will be 4 plus 5, 9. 9 plus 1 divided by 2. And that's how you will calculate it. And for the standard deviation, you will do the same. N1 will be 4, N2 will be 5, and N1 and n will be 9 plus 1, and divide by 12 and take the square root. That will calculate the standard deviation. Since we're using a large sample, therefore it means we must use the normal approximation, even if our N1 or N2 are more than 10. So we need to make sure that our data is normally distribution, or we approximate it to a normally distributed values. And how we calculate the test statistic now, remember now we know that we know that T1 is our test statistic, but we also, since this is approximating to a normally distributed value, so it means we need to use the standardized normal distribution, which is our Z. So to calculate the normal distribution test statistic, which we use the Z-score for, and that is given by that monster formula. Our T1 minus our mean. Remember, we would have calculated the mean. It's easy if you calculate the mean outside of the whole formula and just come in and substitute it. So it will be T1 minus the mean for T1, which you would have calculated it using that formula that we learned earlier on, divide by the standard standard error or standard deviation of T1, which is the square root of N1 times N2 times 1, N plus 1 divided by 12. So we use this formula to calculate the test statistic. And then once we have calculated the test statistic, then we can use the table, which is table 8, I think. Yes, table 8, to go find the critical value, which is also commonly known as the Z value. So we're going to use table 8 to find the critical values. Let's look at an example, and then I will show you how to find the critical values on the Z table. Using the setting of the prior example that we used, if you joined late, we already had an example where we used two factories, factory A and factory B, and B had the smaller factory, and we labeled it as N1 because it had the smallest number of sample size. And our factory B had 4 and factory A had 5, and we also wanted to test at alpha 0.05. And we calculated our T1, which was the sum ranked of both of the values, and we found that it is 24. And since we want to approximate this, remember this is smaller sample size, but we want to approximate it to a normal distribution. So we're going to use the Z formula to do that. And to do that, remember now, our mean is N1, which is 4 times N. Remember I said N is our N. Our N is N1 plus N2. And there we had 4 plus 5, which is equals to 9. So where we see N, we're going to put 9. So 4 times 9 plus 1 divided by 2 gives us 20. And we do the same with the standard deviation. The square root of N1 times N2 times N plus 1 divided by 12. We get 4 times 5 times 9 plus 1 divided by 12. The answer we get will be 4,082. And that is our standard deviation. Now, we can calculate our Z stat by substituting the values. Remember, our T1 was 24.5. So we substitute T1, which is 24.5, minus our mean, we just calculated it, is 20, divided by the standard deviation, which is 4.082. If we calculate this, it is positive 1.1 and 1.10. When we go to the Z table, we always going to leave 2 decimals after the comma. So when you do the calculation, make sure that the answer you get for your Z is always going to be a 2 decimal answer. So now we're going to go to the Z table. We know that we also need to use alpha of 0.05. And since this is equal, it's a two-tailed test. Therefore, on the Z table, when it's a two-tailed test, we need to divide this by 2. So we will divide our alpha by 2 to go find the critical value on the table. So let's go to the table. I'm going to stop sharing that. And I will share the okay, so we need to go to table 8. That is 6, 7, 8. Okay, so table 8, it is this table of ours. So now we're going to look at the critical values. So remember, we're doing alpha divided by 2 because we got alpha, which was 0.05. And since we're doing not equal, because we're testing whether they are equal. So we're doing not equal, which is a two-tailed test. And since it's a two-tailed test, then we divide alpha by 2 by saying 0.05 divided by 2, which gives me 0.025. And then since it's 0.025, I can go to the Z. I can go to the Z and find 0.025 since it's Z alpha divided by 2, and that will give me 1.96. And that will be my critical value. And going back to the presentation, and on the I can then determine my region of rejection. So now I can determine my region of rejection. Since it is two-tailed test and this is a normal distribution, we are approximating to a normal distribution. Therefore, the region of rejection will be in two sides. Might have two sides. So since it's two-tailed and this is normally distributed, so this will be the negative 1.96 and this will be 1.96. And if I look at my Z value, where does it fall? It will fall somewhere in here. And remember, this is my rejection area. So in anything that falls in the shaded area, we reject. This is reject. This is we reject anything that falls in there. And here we do not reject. So our 1.10 falls somewhere in the do not reject. So we do not reject at alpha 0.05, and we conclude that there is not sufficient evidence that the medians are not equal. And that's how you do the test. And an exercise, try doing this exercise on your own, and then we will do it together just now. The only thing they're asking you to do is to calculate your test statistic. So it means you need to go calculate the mean for T1, which is N1 times N plus 1 divided by 2. And you also need to go and calculate your standard deviation, which is the square root of N1, N2 times N plus 1 divided by 12. So once you've calculated both of those values, then you can come and calculate the Z stat by using T1 minus mean T1 divided by the standard deviation T1. Now, the other thing, since I didn't mention this, is to get T1. So it means you need to make sure that you sort your data, order your data from lowest to highest, and put ranks on them. So once you have ranked them, you sum the rank for N1 and N2. So therefore it means this has a smallest sample size. So that will be our N1, and this has the biggest sample size, it will be N2. So once you have ordered it, and remember now the other thing as well to remember is if there are two values like 10 and 10, they happen on the say on different sample sizes. So you need to divide the average position of those two. And once you are done, add them all together, and then that will calculate your T1. Okay. Are we winning? Can we do it together? Or do you want extra more time? Talk to me. More time? Or we can do it together? Okay. You are all quiet. I don't know. So I'll just go ahead and do it with you. The first thing we need to do is rank the values. And since I am going to use, I'm not going to order them, but you will have space to order them from highest to lowest so that it doesn't trick you. So the first value here is 1. The second one is 2 and 5. 5 and 5 appears twice. So I'm going to say it's on position 2 and position 3. Therefore, it will be 2.5. So this one will be 2.5. And this one will be 2.5 as well. And what is the next value is 8. And 8 and 8. So we already counted 3. So it's on position 4 and position 5. So 4 and 5 will give us 4.5 on this one and 4.5 on the other one. What is the next position? So we already counted 5. So we go to 9. It has 2 9s. So 6 and 7. So it will be 6.5 and 6.5 on this one. The next value is 10. So 7, 8, and 9 will be 8.5 and 8.5 on the other one. And the next one, 9 we counted, 10, 12 will be position 10 and 10 we have 2, 12 we have 2 12s, 2 12, so it will be 10 and 11, which will be 10.5 and 10.5 on this one as well. And then we go, next will be 11, 12, 13. So this will be, 13 will be, so there's only one 13. And 15 will be 13. And 16 will be 14. So what we do, we're going to add all of them, all the ranks. So we'll start with the one at the top. I'm not interested at the one at the bottom. I'm only interested at the one at the top because that is our T1. So we just want to calculate T1. I'm not going to calculate the other one at the bottom. So we said that is 13 plus 8.5 plus 10.5 plus 14 plus 12 plus 4.5. And the answer is 62.5. 62.5. Did you all get the same? So your T1 is 62.5. You need to talk to me. Do you agree with me? Nothing on the chat. Please, guys, talk to me. If you didn't calculate it, also let me know so that I don't talk to myself. Okay, so now we need to calculate the mean. Our N1, 1, 2, 3, 4, 5, 6, there are 6, so it will be 6 times. So N1 is 6. N2, 1, 2, 3, 4, 5, 6, 7, 8, there are 8. So 8 plus 6. So to calculate the N will be 8 plus 6, which is equals to 14. So this will be 14 plus 1 divided by 2, which then gives us 14 plus 1 equals 15 times 6 equals 90 divided by 2 equals 45. Our mean is 45. Our standard deviation, which is the square root of N1 is 6 times, N2 is 8 times 14 plus 1 divided by 12. So we say 14 plus 1 is 15, multiply by 8, multiply by 6 equals 720, divide by 12 equals 60. And we take the square root of the answer and we get 7.74. 7.74. I will keep 6 digits at least. 7.7459 67. I'm going to cut it there because I'm running out of space. I'm going to write the whole number down, which is 7.77459666692. Remember to keep all your decimals when you do your calculation. So now we can come here and substitute into the formula. Our T1, we calculated it, it was 62.5 minus our mean of 45 divided by our standard deviation of 7.74596. Actually, we can write all of them, 66692. 92. And we take our calculators and calculate now. 62.5 minus 45 equals 17.5. Divide by 7.745966692 equals 2 how many decimals must I leave it? 4 decimals. So the answer I get is 2.2592, which is option number 1. Any question? Absence of questions, then I was gonna do exercise 2, but I will just leave it out for now. If we have more time at the end, we can come back and look at it. But what exercise 2 was going to do is you need to be able to know how to calculate the mean, the standard deviation, and also go find the region of rejection if we are doing a greater than. So it means somewhere in the question, they asked about the greater than, which is the left, and left is less than. And they say if distribution of A is shifted to the left, so which is less than, and you need to calculate your Z test, and then you need to say, state your decision. Maybe we should do this because and then the last 30 minutes or so we can concentrate on the sign rank test. Okay, so here they give us the sample size. Suppose you wish to compare two treatments, A and B, based on the independent random sample of 15 observations of each. So since both the observation are of the same size, so our N1 and our N2, they both are equal to 15. Our T1, they're telling us our T1 is 173. So that our sum ranked values. If a Wilcoxon rank sum test is used, do the data indicate the distribution of A is to the left of distribution of B? Test at alpha 0,05. So the first thing we need to do is to calculate the mean, T1 mean, which is N1 times N plus 1 divide by 2. Remember that our N1 is 15 and our N will be 15 plus 15, which is 30, plus 1 divide by 2, which then gives us our mean will be 30 plus 1 equals 31, multiplied by 15 equals 465, divide by 2 equals 232.5. Remember all this. If we're going to calculate the test statistic, let me just do that. I'm going to just, because I want to delete this after that. The Z stat is T1 minus mean T divided by the standard deviation of T1. We know our T1 is 173 minus the mean, we just calculated it, which is 232.5 divided by, we need to go calculate the standard deviation. So I'm going to remove this so that I can have space for the standard deviation calculation. Okay, so now we need to calculate the standard deviation, which is the square root of N1 times N2 times N plus 1 divided by 12. So therefore, this will be the square root. Our N1 is 15 times 15 times 30 plus 1 divided by 12. Taking our calculator, 30 plus 1 is 31 times 15 equals 6,975 divided by 12 equals 581. Take the square root of the answer and we get 24.109. 24.109. 1269, and we take this value and we substitute it into the equation 24.109. 1269. Okay. Okay, so now we can calculate our values. So, oh, sorry. Remember our mean? We calculated our mean and we found that it's correct. We just calculated our standard deviation and we found that that is correct as well. So what we're doing now, we're going to calculate our test statistic. So calculating the test statistic, 173 minus 232.5 equals minus 59.5 divided by 24.1091269 equals minus 2.47. Remember, we need to just keep it to 2 decimal, and that is correct. Now what's left is two things: finding the region of rejection and making a conclusion. Now, finding the region of rejection, based on the question that they told us, or the information that they provided us, they said it is to the left. When it's to the left, it means it is less than. Therefore, it means it's a one-sided test. Then it means our alpha, what we see is what we use, 0.05. That is our value of our alpha. So we go to the Z table. Remember table 8, if you go there, you do not have to divide Z alpha divided by 2. You are just going to use alpha of 0.05. Z, remember now, yours is not going to say alpha divided by 2. We're just going to assume that it is Z alpha, and our Z alpha is 1.164. Maybe I should show you what I am referring to as well, so that I don't just scream at things. You can see what I am talking about. So what I'm talking about is, remember when we were, I can just click here and delete. When we were talking about the two-sided test, we were using alpha divided by 2. Now, since we're only using one-sided test and our Z is 0.05, is still, the logic will still work the same. So we go to where Z is 0.05, and that will be our critical value, which is 1, nope, it's not. My bad. Wait, sorry. We need to go to table. I hope you do have it. Let's go look at the Z table. There should be a Z standardized, cumulative standardized normal distribution table. This is the table I'm referring to. Let's see if we get the same values. So we know that we're looking for, on this table, our Z 0.05. We can go to the negative side of the table. So sorry, you always have to use the negative side of the table for this one. If you're using this table, which is called cumulative standardized normal probabilities, we use the negative side to find the critical value. So we're looking for Z alpha, which is Z 0.05. Therefore, it means this value, we should find it inside the table, and then we go outside to go find our Z value. So let's look for 0.05, 0.05, and that is both these values, they almost look exactly like that. So if we go out and when you go up, we will have to use both of them. As you can see, the answer here is 1.6 from the side, and at the top we're going to use both of them, because if I round it down or up, I get 0.51, and this one I get 0.5, like that. So they both, I need to add a 5 to them to make sense. So we just use both of them. And if you look at that, it's the same kind of value like I got when we were looking at table 8. And it doesn't really matter. So this value of alpha once you get the value of alpha, whether you're doing alpha divided by 2 or alpha, the value you see here, you can use that, which is the same as 1,645. So that will be our critical value, our region of rejection. So going back to the presentation. Tell me if you see the presentation. Okay. So I guess you are seeing the presentation. I'm going to leave it for now at this point. So we know that is the region of rejection. And since we're doing the to the left, it means to the left, it means the region of rejection should be to the left. Anything that falls this side, we reject. Anything that falls here, we do not reject. And this is minus 1.6445. Our I think this is the only problem with the sign that they used. But if I look at minus 2.47, it will fall in the rejection area. And this says we fail to reject. So we cannot have both of them. So this is the incorrect one because we fail to reject. We reject at minus 1.645 region of rejection. If it was on this side, it would have been a positive 1.645. And we will also going to reject if it was the greater than. It will have fallen on there. We would have not rejected. So since we're not doing a two-tail, and based on the information that we are provided, we do not reject the null hypothesis. I think this, they just make a mistake with the sign. It should have been the correct one. Okay, and that's how you do Wilcoxon rank sum. Now let's move on and look at how we do Wilcoxon sign rank test. So with the sign rank test, like the word it says, we're going to be using the sign. So here are the following steps that you need to follow when you do this test. For each of the sample item, you will need to compute the difference because this is paired population. So it means population 1 and population 2 are related. So you're going to be able to find the difference between the two population. It's like doing the before and the after analysis. So you're going to compute the difference, and that difference will be your difference GI between the two measurements. Then you're going to ignore the sign that you get, because when you're doing a difference, so if one value was 20 and the other value was 15, so it will be 20 minus 15, which will be 5. And another value might be 15 and the other one will be 20. Therefore, it means it will be 15 minus 20, which will be minus 5. So now you will have a positive 5 and a negative 5. You're just going to ignore the negatives and add all the values as positive so that then you get the absolute values. Then what the other thing is, you're going to omit all the zero differences. We don't have to count the zero differences. Then once you are done, we can give back the negative signs to the data, and then we start assigning rank. So remember the rank starting from lowest to highest. And if there are ties, same procedure happens. You're going to take the average of the position. Oh, I already covered that. You reassign the signs to the ranks, and then once you are done, then you can calculate the test statistic, and your test statistic will be the sum of the positive ranks, not the sum of the negative ones, but on the positive ranks. Okay, let's look at an example of how we do this. So to find the test statistic, remember, is the sum of all positive ranks. And to find the critical values, we're going to use table 7. Remember, previously we were using table 6. Now we're going to use table 7. It's called Wilcoxon sign rank test. Sign rank test. It's table 7, and I will show you how to find the critical values. Similar, we're going to use your N1 and your N2 and your upper. We're going to find the boundary, the upper boundary and the lower boundary. We're also going to find or use the table using the alpha values. Okay. The other thing you need to do is to also calculate the test statistic. And calculating the test statistic, it means you're going to use your the mean and the standard deviation. So it's going to go back to the Z, but we use the mean and the standard deviation. Now, since both of them are the same samples from the same population, so your N, N1 plus N2, your N times N plus 1 divided by 4, because then now they come from 2 populations, so it will be double. So we divide by 4. The standard deviation, it will be the square root of your N times your N plus 1 times 2 times N plus 1 divided by 24. Okay. So how do we do this? Then, once you've calculated your standard deviation and your mean, you can then calculate your test statistic or your Z test statistic, which then is your sum rank positives. Remember that your test statistic sum rank positives minus the mean you calculated previously, remember, using that formula, and the standard deviation using the same formula that we just went through. And once you've calculated this, then you can go find the critical value and make a decision. In terms of stating your null hypothesis and your alternative, your null hypothesis will say the 2 population mean are the same, and the alternative will say they are different or they are not the same, and so forth. And then you go and find the critical value on table 8. So 2 things I've already mentioned. For the test statistic of the sum rank, the critical values of those sum rank, especially if we want to look at the upper boundaries of those sum ranks to say where they fall, whether we reject them or not, we use table 7, which is sum rank. For the test statistic, when it approximates to normal distribution, we use the Z test, which is this. And the table we use, remember, is the Z table that we always been using. Okay, so let's look at an example so that I make things clearer. In Wilcoxon sign rank sum test, the test statistic, which is what they've already calculated, the positives and the negatives, and then they calculated only the positives, and we have our T1, which is 91. We're told that there are 18 observations, so it means there is 18 and 18 pairs, of which 3 have 0 differences. And this is a 2-tailed test performed at 5% level of significance. We're not going to the Z test as yet. We can use only the test statistics as given right now. So what we need to do is we need our, we know what our T test is, our test statistic is. we go to table 7, which is critical value of Wilcoxon rank. We use our N, which is 18, our N, and we're going to use our alpha of 0.05 because this is our N, our alpha of 0.05, and we go find the critical values. So let's go and find the critical values. I need to stop sharing this one and go to the table. Okay, so table 7 looks like this. So we need to look for alpha two-tail. Remember that? They said we're doing a two-tail, and that's what they said it explicitly, two-tail test. So we need alpha of two-tail test. Alpha of two-tail test of 0.05, which is that one. For two-tail test, then we need N of 18 and our upper tail area and lower tail area. Okay, and we found that it was 40 and 131. Remember that. So I didn't mention that. 40 and 131. Now, our lower is 40 and our upper is 131, so that I don't forget that. This is T1U, T1L. Now we need to come and answer the question here. So if this is a two-tail test, so this is 40 and this is 131. We know that anything that falls this side, we reject. Anything that falls this side, we reject. Anything that falls here, we do not reject. We do not reject. So the critical values, it's 90 and 30. We know that that is not correct. The critical values is lower is 40 and we know that that is correct. Actually, we could also even stop right there. But if we don't want to stop right there, the null hypothesis is rejected. The null hypothesis will not be rejected. And this is not how we state the rejection area. So our null 91 falls in the do not reject. We do not say we will not reject. We always say we do not reject the null hypothesis. Test results are conclusive. So all of them are not correct. So don't fall into the trap of looking at what they wrote and say, oh, but then it makes sense. It does not, because in statistical way, we always state that we do not reject the null hypothesis or we reject the null hypothesis. We do not say we will, because it's not something that we will do in the future. It's something that you're doing now because you're looking at the results right now. Okay. Any question? If there are no questions, you have an exercise to do. Oh, actually, let's do it together as well on this one, because then this is the Z one. So that the first one we were using, the test statistic from the positive sum rank. Now we need to use the Wilcoxon sum test. And here they're asking you actually to approximate. So because of that, we are told what N is. Our N is 30, our T positive is 354, our Wilcoxon rank sum test, that's what they're telling us, determine whether we can infer at alpha 0,05, at alpha 0,05 if the two populations differ. So therefore it means it's a two-tailed test. Since they say it differs, because then if the opposite will say it's the same and then it's different, meaning it's an equal sign. Which one of the following statement is incorrect? The null hypothesis will state that they are the same, which is correct always. It's going to say it's equal, or it can be less than or equal, or it's greater than or equal, or something like that. So they are the same. The alternative, we say they are different. Location of one is different. So since they are mentioning that they differ, then that means that is correct. We're doing a two-tailed test and we're using the Z. Remember, Z, two-tailed test, it will mean Z alpha divided by 2, which is Z 0,05 divided by 2, which will give me Z of 0,025. And earlier on we used it and we found that it was 1.96. You can also go to table E8 or table 8. You will see that under the Z alpha, you will see Z 0,025. It will give you 1,96. So that is our critical value. The region of rejection, if it's in the positive, it will say it's 1.96. So that's what we just got. Now, here they are asking a very good one. They are asking that our p-value will be 0,062. What they didn't give us here is the Z test. So what we need to do is to calculate the Z value. So remember the Z value, we calculate it by using this formula, ET. We must write that formula down. ET equals N times N plus 1 divided by 4, and standard deviation, which is the square root of N times N plus 1 divided times 2 times 2N plus 1 divided by 24. And our Z value, remember, that is a Z. Z will be Z stat is T minus ET divided by standard deviation. We already know what the answer would have been, because then the region of rejection is correct. So, but to calculate the p-value, what we need to do is the following. The first one is to calculate the p. So ET, it was N times N plus 1 divided by 4. Our N is 30 times 30 plus 1 divided by 4, which is equals to 30 plus 1 times 30 equals 930 divided by 4 gives us 232.5. 232.5. The standard deviation, QT, square root of n times n plus 1 times 2 n plus 1 divided by 24, which then it is the square root of 30 times 30 plus 1 times 2 times 30 plus 1 divided by 24. So the formula, we can start with the 2 times 30 is 60 plus 1 is 61 times 30 plus 1 is 31 times 30 equals 56,730 divided by 24 equals 2,363 and take the square root. And that gives us 48.61. 48.61 841215. Now we need to calculate our Z stat. And calculating our Z stat, remember it's T positive minus the ET divided by the standard deviation. T positive is 354 minus our ET was expected value was 232.5 divided by our standard deviation, which is 48.618411215. Calculating 354 minus 232.5 equals 121.5. Divide this by 48.618411215 equals, and I get 2.499 some number. So I need to round this off to 2 decimals. So rounding it off to 2 decimal, then it means the answer I get here will be 2.50. Since I have my 2.50, I need to go find my p-value. A p-value is the probability on the table. Remember when we went to the Z table and I showed you the negative values? Now, this is the value we use from the Z score outside of the table and go inside the table. We need to find the value that is 0.062. Since this is positive, then it means the value we find on the table will have to subtract it from 1 and then multiply that value by 2 because we're doing a two-tail test. Okay, so 1. Since the value is positive, we're going to subtract the value we find on the table. Since 2.50 is positive, what we're going to do is to say 1 minus the value we find on the table. Once we found that value on the table, since we're doing a two-tail test, we're going to multiply the answer that we get from here by 2. Okay, let's do that. See how many steps you need to do to get to the p-value? So many steps. Let's go find our critical value on the table. So we need to go to the cumulative standardized normal distribution table, which is the Z table. Remember, we're looking for Z equals 2.50. So this is the negative side of the table. So we're going to go to the positive side of the table. Move too fast. So this is the table we are looking for. So what we're going to do here, we need to look for the Z value, which is Z 2.50. So it means on this side, we're going to look for 2.5 going down, and at the top here, we're going to look for 0.00 because the last digit, we find it on the table. The last digit on the table, it will be our last digit. That is why your Z, you always have to leave it at 2 decimal. So here running down, we need to find 2.5. Going down, 2.5, I found it is just right at the bottom of the page. And at the top, this is 0.00, so we can use that column since I'm gonna go up. And that is the value we find on the table, which is 0.9938. Remember we said we need to subtract this value from 1. So we say 1 minus 0.9938 equals 0.0062. And going back, so remember those two numbers, 0.9938 and 0.0062. So going back to the presentation. Can you see the presentation? I hope you can. So now we do what we said we're going to be doing. We subtract 1 minus 0.9938, and we find that the value is 0.0062. If you are not careful, you will say this is also correct. It is not correct because if we're going to be doing it is different, therefore it means it is a two-sided test. It is not equal. Therefore, it means we are going to have to multiply this answer by 2. So this will be multiplied by 2, and the answer we get should be 0.0124 should be your p-value. And this is only because we're doing a two-tailed test. If it was a one-tailed test, that will be correct. So I forgot to tick that one. That would have been correct. So the incorrect value is just that one. As you can see, these things are very, very time consuming. So in the exam, you will tick, tick, tick. You don't have to go through all the answers like I did. So automatically, if you know, if 1, 2, 3, 4 are correct, then it means number 5 is incorrect. But you will never know. You just need to make sure that you calculate all of them and eliminate whichever one that is left. Okay, and with that, I think I will stop right here and go and summarize and recap on what we've learned so far. We've learned how to use Wilcoxon sum strength test to calculate the test statistic, to find the upper boundary and the lower boundaries when we have the smaller sample size. Then we also did when we have a bigger sample size, or we want to approximate it to a normal distribution by also finding the Z statistic and finding the critical value on the cumulative standardized normal distribution table or on table number 8, and using your Z alpha, whether it's when you do a two-tail, you will say Z alpha divided by 2. If you're doing a one-tail, it's just the Z alpha, and find the critical value and then make your decision. Then we also looked at the Wilcoxon sign rank sum test. So with all that, I think that concludes what we did today. If you have any question, feel free to ask. Remember, if you still don't understand most of the things that we did throughout the course of the season, the course of the semester, you still have a chance to book your one-on-one session. It's a 1-hour session where we can discuss any topic that you feel you're still uncomfortable with, and we can go through it in detail as you're working through it for an hour, me and you. So it's up to you. I have sent the details on the WhatsApp, so you should have that kind of information on how to request that one-on-one. Since I have so many modules that I assist, it will be best if you can be more detailed when you send those emails, and not only send it to me and send it to CT and TAC so that they can have a copy or a record of my interaction with you. With that said, thank you for coming through. And if you haven't put your student number on the chat, feel free to do so. Otherwise, I will see you next week, Tuesday. Enjoy the rest of the day and the rest of your week. Bye.
Thank you, Ms. Mboye.